Imagine you're Albert Einstein. You've reshaped physics, you've bent space and time, but now you're furious. Not at the universe, but at a strange new idea from quantum mechanics. An idea that says two particles, light years apart, can communicate instantly. No signal, no wires, just spooky action. Einstein called it absurd, but quantum mechanics said, this is real, and today experiments confirm it. Welcome to one of the most unsettling mysteries in all of science. This is the EPR Paradox. And yes, your reality might be weirder than your wildest dreams. Let's start simple. In the world of the very small, atoms, electrons, photons, quantum mechanics rules. But this world is weird. Particles can be in more than one state at once. They don't have definite properties until we measure them. This is called superposition. An electron can be spinning up and down at the same time until we check. Only then does it choose one outcome. And that's just the beginning. Now we introduce the real mind-bender, entanglement. Entanglement means this. Take two particles, make them interact in a special way. Now they're linked. What happens to one instantly affects the other, no matter how far apart they are. Example, create a pair of entangled photons. One will always be the opposite of the other. Measure one's spin, it's up. The other, instantly, will be down. Doesn't matter if they're on opposite ends of the galaxy. It just happens, like they know what the other is doing. But how? Is information traveling faster than light? That would violate Einstein's theory of relativity, and this is exactly what drove Einstein mad. In 1935, Einstein teamed up with Boris Podolsky and Nathan Rosen. Together, they wrote a now famous paper, the EPR Paradox. They argued, if quantum mechanics is right, then either 1. Information is traveling faster than light, which violates relativity, or 2. Quantum mechanics is incomplete. There must be hidden variables that determine the outcome before measurement. Einstein believed in realism, that particles had definite properties before you looked. He couldn't accept a universe that rolled dice at every turn. He thought entanglement was a flaw, a sign that quantum mechanics was not the full story. But others weren't so sure. In the 1960s, Irish physicist John Bell asked, can we settle this once and for all? He devised a test, Bell's inequality, that could tell whether quantum mechanics or Einstein's hidden variables were right. If particles behave like Einstein hoped, certain statistical limits would never be broken. If quantum mechanics is right, those limits would be broken. So what did experiments show? Again and again, Bell's inequality was violated. Quantum mechanics wins. The spooky action is real. There are no hidden instructions. The universe is rolling dice. Einstein lost that battle. But the war over interpretation was far from over. Okay, let's be clear. Entanglement does not allow you to send messages faster than light. You can't use it for instant texting across galaxies. Why? Because the outcomes are always random. You measure one particle, its spin up. The other, instantly spin down. But you couldn't control what it would be, so there's no way to transmit usable information. Still, something is happening, instantly, across space, and we still don't fully understand how. Einstein called it spooky action at a distance, and in a way, it still is. This isn't just a quantum fairy tale. Entanglement is real and powerful. Quantum cryptography uses it for unbreakable encryption. Quantum teleportation lets us transfer states across distance. And quantum computers might one day use entangled bits, qubits, to perform calculations we could never dream of. And in 2022, a Nobel Prize went to 3 physicists, Alain Aspect, John Clauser, and Anton Zeilinger, who pushed these experiments to new heights. They showed beyond doubt, entanglement is not just weird, it's part of nature. So what's the takeaway? The universe is non-local. Two things can be deeply connected, even across cosmic distances. Reality is not what it seems. Your choices here might be entangled with outcomes over there, and perhaps everything is more connected than we'll ever understand. This is the Mindbender. Hit subscribe and join us as we unravel the weirdest truths about the universe, one paradox at a time.